Hi guys, this is John, and I'm here to offer some tips about a reversal algorithm. Now, I came up with two algorithms, one on my own and one when I saw someone else think of it, but I helped them refine it. So the first one, the one I came up on my own, what we do for this one is we know that we have to end with E, D, C, B, A, no. Now if we pay attention, crap, go back to pencil. If we pay attention, we'll see what we already expected. The B is before A, the C is before B, the D is before C. If we look up here, we'll notice that we have this pointing to what was before it. This pointing to what was before it, that pointing to what was before it. So, what I figured we could do, and of course the E is going to end up over here. So what I figured we could do is move everything to the right of E, but do it in a particular order, and that would reverse the list. So let's call E the old last or something. This doesn't look like English at all. Just trust me, that was supposed to say old last. So E is the old last. Now, how do we get our things over there? Let's look at the steps of what my algorithm is. First, we move over our A, and we end up with B, C, D, E, A. Then we move over our next thing from the first, put it right after E, between E and A. So we'll have, B, C, D, okay. We'll have C, D, E, B, A. Now, stay there. That just disappeared. Let's try that again. B, C, D, E, A. And then we have C, D, E, B, A. Then, as you can probably expect by now, D, E, C, B, A. And then finally, E, D, C, B, A. Now, how did we get this? As you can see, every time we add something, we add it after old last. Remember, E is named, come on, just go to the pencil. E is named old last. We don't want to ever change what old last is pointing to. We want it to always be E, because we're always adding something after E. If you also notice, whenever we add the first thing to the end, the thing after it becomes the first thing. And we can use that to make it so this will point to what was before it, just by inserting it right here. And by inserting this here, it's now pointing to the thing that was before it also. Now we see, every time we do this, we have the thing we're adding point to the thing that was originally after E. Up here, the thing that was after E is B. Now we have C pointing to it. So, we can come up with some general rules. First, we move the former head past E. Okay, then we update head. Now, you'll have to be careful on the order of these things. I'm not necessarily doing it in an order that will work in the code. You'll have to figure this out. We also have to, let's call this thing we just added old head. So we have to make old head point to the thing that was after D. Old head next points to thing originally after D. In this case, we had B as old head. I don't know if you guys can see my cursor. Okay, so in this case we had B as old head. The thing that was after E was A. Old head next points to A now. And in this case, A was the old head. The thing after E was null. A next is null. And so, I forgot what I was gonna say, but I really should have scripted this. Let me collect my thoughts. So we've moved this former head to old head. We moved it here, we pointed it to that. We also have to make it the next of E every time we move it here. So that's part of this step. E next is old head. But since right there we changed E next, we lost our reference to this thing that was also E next. So we have to save this value before we lose reference to it. And then, let's say with a temporary variable, then we can use that temporary variable that saves this memory of A. We can point B next to that temporary thing. I don't know if I'm making much sense, but you'll have to figure these things out while you code it. So now, I'll let you pause if you want to look at this. I can zoom out. But I'm going to move on to the second algorithm, which happened when someone just flipped the direction of the arrows. I came up with it that way. So you can always rewind if you want to see this stuff. How do I increase the size? You know what? Let's just start fresh document. So, the second method. Dang it. Sorry, I'm going so slow, guys. No, we shouldn't have that there. So, let's just pretend E was pointing to null. I just saw, actually today, I saw a student say, Well, what if we just flip the arrows like this? And I thought of a way we can actually do that, although it's not as simple as it looks. What you have to do is keep track of the end and traverse the list until you have previous pointing here and present pointing to the end. Then you'll want the end next to point to previous. Then you'll want this to be the new end. So you now have E, D. We'll call D the new end. Now we loop again to find the thing that's right before this end. So we check A. Is the next thing the end? No. We check B. Is the next thing the end? No. We check C. The next thing is what we labeled end. So C is going to be our value for previous. Currently, D next is E. But we want D next to point to C. Now that we've found C by looping through, we can make D next point to C. So, I think you can achieve this with nested while loops. One while loop finds the thing right before the end, whatever we label as the end. And then the other, no wait. Yeah, I don't exactly know the conditions of the loop, but I think the inner loop would find the end. The outer loop, I think, would go until your end is head. Because we still want to have head point to A the whole time until we're done flipping all the arrows. Otherwise, we won't be able to find B, C, D, all those things. So this is still head the whole time up until we have it reversed. I'll draw it in the order he drew it. So this is both head and end, based on the moving end variable we had. Once that happens, we don't want to call this the head anymore. We want to call this the head. But we don't actually have access to this anymore, so you'll need some variable that stores it before we do any of the flipping. Otherwise, you'll never be able to find this E, the memory location of it, to set head to it. Anyway, that's the second algorithm. It might sound confusing, but what I thought of is loop until, now you don't have to call it end, you can call it temp if end is confusing, because it doesn't actually point to the end of anything. It's just the end of the backwards moving link list. That's why I called it ends. We have a forwards moving and a backwards moving, and the list is reversed when the whole thing is backwards moving. So loop until head is end. Each time this loop happens, find the thing before end. I hate writing like this. find the thing before end. And then do end.next is the thing you just found. So that way, instead of D pointing to E, you have E pointing to D. Well, actually, both are happening at the same time. But once you have this as end and this as previous, this is still pointing there, but you'll want to change this to point that way. And that happens up until you reach this head equals end part. Once you get there, you'll notice A is still pointing to B. So after you finish all of these loops, you would want to set A next to null, because A is actually the end of our list now. And then after you've done that, then you can set this original end of the list, the E, you can set it to the head. You just need some variable to keep track of where it is, because if you look here, we don't have anything tracking it right now. You'll have to do that on your own, figure that bit out. But that's all for my tutorial. Hopefully that helps, and hopefully I didn't give too much away. I tried to be vague, but also as understandable as I could. So yeah, good luck on the reversing, and I guess I'll see you all next week. I have office hours tomorrow. I'm gonna try out some later office hours. This week I have to because of, because I had a test yesterday during office hours. But if it turns out people need a later Friday office hours, I could switch my 1 hour on Monday to some later hour on Friday permanently. So I don't know. If the poll I made is successful, then maybe I'll do that. Anyway, good luck on the rest of homework 4. See you all later. Bye.